I'm Johan Els. I'm a professional town and regional planner at Virtual Consulting Engineers. I'm professionally registered with the South African Council for Planners. I studied town and regional planning at Northwest University, formerly known as Potchefstroom University for Christian Higher Education. After I finished my studies, I worked in KwaZulu-Natal as a town and regional planner, first for provincial government and then joined the local authority. After that, I moved to England, where I started my career more in transport planning. Town and regional planning is very specialised in the UK. It's either strategic planning or development control, and I just wanted to break out a bit, so I started getting more interested in transportation planning. And that also made me decide to do my Master's MSc in Airport Planning and Management at Loughborough University. I worked on various airport projects, but not only airports, also other various transport and traffic type of projects in the UK. And after 8 years in the UK, I relocated to Australia, where I was also involved in transportation planning. I think the thing about town and regional planning, people think it's very rigid, but there's so many different ways and aspects about it. Hence the reason why I decided to go into transport planning. I know in South Africa it's still traffic impact assessments and these types of projects needs to be signed off by a professional engineer. But in the UK and Australia, it's your planners as well that get involved and can sign these types of projects off. I know the British Council for Town and Regional Planners also developed a chapter specifically for planners. I was also a member of the Australian Institute for Transport Planning Professionals. And I moved back about 2 years ago, where I started my career more into aviation, airport planning and also town planning back in South Africa. The good thing about town and regional planning in South Africa, you get involved in the various aspects of planning, where abroad it's sometimes you specialise in one of the areas or one of the fields. Town and regional planning, I always see it as you start with your strategic planning, your policy formulation, which is basically these days your integrated development framework, which is followed then by your spatial development framework, and in part of that is also your LUMS, which is your land use management systems. This is basically your statutory documents that is at council level or district municipality level, where all your planning applications get assessed through that. Then the next level is your development for planning applications. This can be rezoning, consolidation of plots, township establishment, and that sort of planning applications. The other side of it is where you might work for a local authority, where you have to assess these applications and give approval for that. And then the nicer filter, what I think about planning, is more your spatial development, where you're looking at urban design, where you're looking at your layout plans for a region, township establishment, where you actually do the layout of the township. So that's sort of the various fields in town planning that you do get in South Africa. Normally when you start looking at a development or get approached for a new development, it always starts with the identification of a site. Whether that's in a township area, in a town area, whether you need to do rezoning, consolidation. A lot of times, especially with our housing projects these days, you still need to do township establishment. And that's where you get all your various other entities involved, like the engineers, the geotechs, the land surveyors. Township establishment specifically, where you draw your plans and then you have to get your engineers involved in to see, is there services, what needs to be done to get services to this area, and your layout plan, whether it will fit in well with the engineers, particular stormwater, electricity, water, all sorts. And then by the site identification, you also have to do a geotechnical report to see is the land suitable for the type of development that you're looking for. And then you get your land surveyor. With township establishment, you need to get approval through your surveyor general But that always happens most of the time after the town planning process has been approved or council are happy with the layout, because obviously at the Surveyor General they don't want to keep on changing their plans. So at that process already you get your engineers involved to get advice on the services, you get your geotechs involved with the geotechnical report, and your land surveyors to do the various, the pegging from first the 5-meter contour to see the layouts and how your layout will fit in stormwater and all that, and then up to the approval of the land survey, by the general surveyor. The thing with town and regional planning, it's always a participation process. So you always get all your parties involved from day one. You can get through the whole process and you can get to the end where there's no approval or people jump up and say no, no, no. Specifically with housing development, we get to the point where the township is established. We've got the layout, engineers has been involved. Part of that would be your application. Part of the township establishment application is either a subdivision, which is mostly the case, or there can be rezonings. With that, you get, as I mentioned, involvement from your engineers, your water, all your service levels. So at that point, after the approval has been done, from there onwards, it's the council and the engineers' responsibility. I think the biggest thing these days is GIS. All your requirements when you submit a proposal for all your spatial development frameworks, etc., is always GIS based. So I would say that's the biggest tool that we use is GIS. And it's such a big database that you can just build on. Most of the local authorities do have GIS databases, and for instance your spatial development framework and your local your land use management systems, it's in so much detail that you're supposed to click on a site and it will tell you what is on there, what is allowed to be changed if there's a change of use, and what is not allowed. So it's a very specialized, very in-depth, but again it depends how many layers you want to build that, but that is such a useful tool. That environmental is a big role these days, and your environmental impact assessment, and it depends whether it's a full EIA, the level of EIA that needs to be with every application. It's a lengthy process and it can slow down our planning process, especially with the DFA where you have to submit everything at once to get it running. Time for consultation and everything. It is a lengthy process. I also know when you apply for a planning tender or job, that normally you can't go for the environmental part as well because it's conflict of interest. It sometimes feel that the environmentalist has all the say, and you will, especially when it gets to wetlands, which is already dried up and things like that, they want to keep, and you want to develop, and that whole process of going through that, trying to get approval, it can be sometimes a nightmare. Then again as well, traffic impact assessments is also for major applications quite interesting that you need to provide that to see what more traffic would be generated. There you can go into various traffic and transport models. I know not a lot of engineers are doing that, traffic engineers. You get macro and micro and macro simulation models, and especially the micro, it's like software like AIMSIM, where you can even build the streetscape with pictures and you can actually see and show your client, but there's your building and this is the traffic that's going to pass there, and the chaos, congestion and all that sort of things. There's various acts that we need to abide by. You get your Municipal Act, you get your Development Facilitation Act, your ordinance. The DFA came in basically as a quicker process, but whether it works or not, because of the public consultation and because of the legal process that it needs to go through an application, it's a lengthy thing. You're looking at, for a spatial development framework, to develop one or review one, you're looking at roughly 18 months.
My name is Piet Lombard. from PD Naidu and Associates, Consulting Civil Engineers, and the topic we will be covering today will be infrastructure design for residential, commercial, industrial townships. I've been a consulting engineer most of my life. I started consulting in the 60s. For about 15 years I was working with consulting engineers. Thereafter I joined Midrand Town Council as a town engineer. I was town engineer there for 3 years, after which I went on and became a township developer. I did that for approximately 5 years, but then decided to go back into consultancy. I had my own practice for approximately 15 years, and for the last 8 years I've been working for PD Naidu and Associates. For me, I think hands-on design is probably one of the most important things that one must try and teach yourself to do. You must always try and stay abreast with the latest developments. But in the 60s, to calculate the bearing and distance between 2 points of which you knew the coordinates was impossible. I say impossible, I mean it was just time consuming. You had to subtract the one coordinate from the other, get the y and x differences, use these in formulas, and all these were done by hand. I'm very happy to say that with the software that's available today and that's become available over the years, it's just been more and more productive to do your designs. I think as a consultant you always need to be proud of what you do, and most importantly you have to take responsibility for what you do. In a big company there's a tendency maybe to think that your managers or your directors or the board of directors will take the responsibility, but I think it's very important that we all realize that what we design is our responsibility. Okay, so when you start with a project and you start designing, make sure that you gather the necessary information. Understand what the brief is from the client. Know who's who in the project, who's your town planner, who's your architect. Go to the local authority, find out what their preferences are. They've got certain things in their municipal area that work and things that don't work. Make sure you have as much information, either by physically visiting them and by taking photos, and you know, just get all the information you can. Obviously there's a lot you can obtain via email and telephones and so on, but I think to visit the local authority, introduce yourself to them is already a good start. Okay. So try and do that up front. Try and do your cost estimate that they want on Monday. Try and do that on Saturday and Sunday so that you can spend time with the local authority, but it's very important to go and see them. Establish what the preferred positions, the depth zones and the elevation zones of certain services are. Survey systems, make sure you know what survey system to use. We're bound now to use the WGS 84 system. Stick to that, and when you produce a drawing, put 2 tables on the drawing, one in the old system that they prefer and one in the new system. Here in the Gauteng area we work with 29, going a little bit westwards, maybe switch over to LO 27, but the whole of South Africa goes from LO 18 in Alexander Bay to St. Lucia, LO 33, and make sure that you're in the right corridor when you work with it. Make sure you know what the township boundaries are. Get a SG plan from the Surveyor General. Know exactly what the coordinates and the extremities of the thing is, because the whole design is going to be based on those measurements. And try and find out when this is going to happen. Is it going to be 20 years before there's going to be development upstream, or is it something that's going to come in the next couple of years? And make sure you refer with whatever's going to happen upstream and downstream of your township. One of the best examples that I have is the canal that they built here just off Empire Road The municipality of Johannesburg built that in 1934. They've just come out of probably one of the biggest droughts this country has ever had in 1933. And yet, while that year was going on, these guys were sitting, planning and designing this monstrous stormwater canal. And up until today, it's serving its purpose. And I think that is very innovative and very proactive to have done that. Find out all about bulk services and other utilities, Telkom, Gautrans, Gascore. Find out about these things and make sure that you are okay with that. No one else is going to do that for you. I must say lately the town planners are doing the bulk contribution side of it, but you must know what bulk contributions are all about. Visit the site. Try and take as many people as is practical with you. I'm talking about your design team. Take them with you. And maybe even the other disciplines like the electrical, the town planner, the surveyor, take them all with you. Go to site, have a discussion, look at a septic tank somewhere, look at a building or a shopping complex 2 kilometers upstream from there, and let them know, what the effect of this is. You can discuss it amongst yourself, take photographs, but make sure you visit the site. We've all got checklists for when we start a design. Have you got a contour plan? Have you got the DTM? Have you got everything in place? Take these checklists, customize them, because they don't all work for the same projects in the same way. Customize them, put them in your file, on the front page of your file, and make sure as you do all these things that need to be done, that you tick it off and that these things fall into place. If you want to do something for a client, and you want the next job that client gives out to be yours again, then maybe it's worth spending a bit of time on the first ones. The most important one is dolomite. Dolomite and water, that is something that we've all got to be aware of. This one slide shows you a whole sinkhole that appeared in 1968 in a residential township, and I think 3 or 4 houses, 3 houses just disappeared into that sinkhole. Know what the effect of a disruption of a service is going to be, know what contamination is, and this specifically applies to sewer systems when they start leaking, running out on surface. These things are dangerous, they're life-threatening. Try and go for green developments. Of late we are very conscious of the need for green developments. Green is expensive if you simply try to put a canal in rather than maybe a 450 millimeter pipe. But when you get to substantial stormwater flows, green is probably, it could even end up being, I won't say cheaper than the conventional system of underground pipes, but certainly from a maintenance point and a long-term point of view, probably the better choice. For us as engineers, it's very nice to see what's happening with your stormwater. We tend to put these things into pipes and we never see what's happening to it. So to have a canal with gabions and terraces and steps in it is just nice for an engineer to see that. Phase development, there's always the question, do we start phasing it from the higher end or from the lower end? Look at your bulk services, look at where your reservoirs are, look at where your sewer outfall is, and quickly do that calculation. Put sleeve pipes in. There's always a need for an electrical cable or a data cable or a telecom cable to be drawn in afterwards as an afterthought. When you've presented a set of drawings that goes out to construction, there's always some revisions happening on these drawings. And make sure that that is done in a proper fashion. Put revision clouds around the revisions, number them properly, and explain what it is. Don't just have a line there that says drawing changed. Cutting corners is a dangerous thing to do, but certainly if it's a product that provides you with the same specification and there's no reason why you can't use it, then certainly. Right, water reticulation. You need to know what the average daily demand is. You need to know what the peak factors is that need to be applied. You know what the fire demand is. You need to know the reservoirs in the area, what the elevation of the reservoir is, what the storage capacity is, what the static head is, obviously. The pipe preference we've covered. Make sure you know what the pipe preference is, not only with the type of pipe, but also with the couplings, with the, is it a Z-lock coupling, is it a big tolly coupling, what the preferred diameters are, valves, are they clockwise or anti-clockwise closing, are there spindles rising, seal types, valve boxes, all these things you need to know. Fire hydrants, very important, probably the most important. For myself, I found out that a very easy and user-friendly way of doing that is simply to take one of your hydraulic formula, put that on Excel, and play around with stuff like your diameters and your roughnesses. Play around and just see, you know, if I make the pipe longer but smaller, this is what happens with the head loss. It's so satisfying to spend 15 minutes with that, and at the end of it know exactly what happens. So when you do your design, there are two things about hydraulic design, and the one thing is that at any junction, for continuity of flow, the sum of your flows at any junction should be 0. And then for continuity of pressure, the head loss in a system, if you consider the clockwise flow as positive and the anti-clockwise as negative, the sum of the head loss in a system should be 0. And then ultimately you produce tender drawings which then get developed into working drawings. And these have to be clear. They must, when the contractor unrolls that roll of drawings, he must know exactly what to do. You as the designer might know exactly what your intention is and how you've designed it, but you must convey this across to the contractor. Contractors talk amongst each other. Everyone says that the drawings coming from your company are the drawings we want. Then as far as the sewer is concerned, again, know what the average daily flow is, the peak factors you're going to use, the infiltration you're going to use, and certain municipalities want their sewers to flow 60 or 70 or 80% full. Make sure you understand what the mid-block sewers are all about. Drainage zones, this is very important. When you have a big township, break it up into drainage zones. Take each drainage zone and give it a hierarchy and also a numbering system. Do your numbering system in such a way that if the contractor picks up the phone and he tells you there's a problem with manhole A025, you know exactly where to go and look for it quickly on a drawing. Have a pipe and manhole preference, the materials you get from the council again, what they prefer. Benching of a manhole is a very important thing. That's where your energy losses occur. Rising mains are there to carry the effluent from the pump station down to where it's going to be treated. Make sure that that rising main can one day be used as a gravity main again. Know what your pump storage is, how many pump starts you want to allow per hour, what happens if there's a pump breakdown or a power failure or whatever the case may be. Stormwater. Stormwater is one of the disciplines that I feel most strongly about when it comes to having regard for loss of life, damage to properties, erosion. This is what stormwater does. Stormwater causes havoc when there's a big storm. You must know where the catchment areas are. You must know what the lengths of them are. Obviously, the slopes, the runoff coefficients that you're going to use. Not only on the day when you do the design, but somewhere in the future there's going to be a development. And development, as we all know, that causes extra runoff, and that is going to create problems. A 1 in 20 year flood must have the same effect on a development than what the situation was before development. The way to deal with this is to provide a attenuation pond. Culverts. Culverts are things that normally take water from one side of the road to another side of the road. It can be circular culverts or rectangular culverts, but these normally there's changing velocities happening at the entrance, happening at the exit, and these have to be controlled. They have to be managed, and they have to be and erosion protection has to take place at these culverts. Know what your major and minor systems are, stormwater systems. Make sure you have a proper set of drawings so that the local authority can know that this is the capacity of your attenuation pond, this is the type of storm they had, there was a problem with it, something needs to be done about it or not done about it. Then moving over to roads. Roads, there are two aspects to it. There's the geometric design of roads and there's the structural design of roads. Geometric designs, you need to look at the different types of roads that you get. You get trunk roads, distributor roads, access roads, collector roads. You need to have a traffic impact assessment study done. You need to know what the speed zones are going to be on these roads. Curvature, super elevation, transition curves, these are all degrees of curvature. These are all terms that you need to equip yourself with. On a geometric design, you need to do slip lanes, tapers, bus lanes, auxiliary lanes like climbing lanes, deceleration lanes. All of these lanes have to be done at certain rates and certain widths and certain slopes. When you do your intersections, make sure you do a contour design of your intersections to see where there's going to be water ponding. When it comes to the structural design of the road, you need to know what the kind of materials are that you will be using. You need to know what the in situ or borrow material is. These classifications normally vary from a G1 right through to a G9, and you must know what the properties of these different materials are. To do a structural design on the road, you need to be scientific in your structural design of the road. How much traffic is going to be on the road? Heavy traffic, E80s. What the design life required for the road is, if any maintenance, to what degree, what surfacing type are you going to use, what are the weather conditions of the area in which these roads are going to be built. One needs a proper geotechnical investigation, a centerline survey if you're talking national roads and provincial roads. These things are all is information that is required before the design of a road can take place. As far as risk is concerned, I think it's important for you to think that you are not insured. Make sure that when you do a design, that you are that the risk you're taking is a calculated risk. In summary, I can say that over the last decades, standards have been set, they've been tested, they've been revised, so they're there. Make use of them. Do whatever design you do it according to the minimum standards that are required. Always make sure that safety and quality of life is number one on your list of priorities. Take ownership of your designs, be responsible. You need continuous professional development. You need to continuously step up and make sure that you have the latest design software, the latest methods at your fingertips.